Introduction to Graphs. We have learnt about graphs in previous classes. There are many ways of representing the collected data as bar graphs, pictographs, pie charts and histogram. In this chapter, we will learn about line graphs. Let us recall how to plot points on a number line. A number line helps us to tell the position of points that lie along a horizontal straight line. However, this method is not so helpful if the points are placed randomly in any direction in a two-dimensional plane, not necessarily on a straight line. In order to plot such points on a two-dimensional plane, we use number plane, which we call a Cartesian plane. Number plane. A number plane has two axes, horizontal axis and the vertical axis. The horizontal axis is called x-axis and the vertical axis is called y-axis. To locate a point on the number plane, we use an ordered pair of numbers called coordinates. The x-coordinate or abscissa is always written before the y-coordinate or ordinate. Cartesian plane. The number plane is also called Cartesian plane. In the 17th century, a French mathematician, René Descartes, invented a coordinate system of determining the position of a point in a two-dimensional plane by considering its distance from both the axes. This system came to be known as Cartesian system. Any point A in the Cartesian plane can be represented by an ordered pair x, y, where x is the distance of the point A along the x-axis, called x-coordinate or abscissa, and y represents the distance of point A along the y-axis, called y-coordinate or ordinate. Uses of graph. A graph is very useful in representing the data. It can be used to represent the relationship between various data elements such as time and distance, voltage and current, pressure and force, and many other such relationships. They are used in medical treatment, that is, a doctor uses the graph to check the variation of fever of a patient, blood pressure, etc. It is also used in engineering constructions, geographical calculations, and many other fields. Almost each and every field requires the use of graphs, and hence, they are very important in our real life. Let us study some graphs based on real-life situations. The average speed of a car is 30 kilometers per hour. Plot a distance-time graph of the car. It is given that the average speed of the car is 30 kilometers per hour. We can calculate the amount of distance a car travels in a given amount of time by simply finding the product of the average speed and time. Let the distance traveled by a car in x hours be y kilometers. Since distance is equal to speed into time, so y is equal to 30 into x is equal to 30x. The table shown here is representing the relation between x and y, on the basis of which we will draw the distance-time graph. So children, in this way we can draw different graphs for different types of data. One more example is perimeter side graph for a square. We know that perimeter of a square is given by perimeter of a square is equal to 4 into length of each side. A perimeter side graph shows the representation of the values of the perimeter for a square with a given side. Plot a perimeter side graph for a square if the length of the square takes the values 6 cm, 12 cm, 18 cm, and 24 cm. To plot the required graph, let x represent the sides of the square and y represent the perimeter of the square. Now, perimeter of a square is equal to 4 into side, so y is equal to 4x. The table shows the relation between x and y. The required graph on the basis of the table is as shown. So children, these were some examples of methods of plotting different graphs. Following the same, you can draw many more.